What is a trace in distributed tracing? Imagine trying to follow a package as it moves through many different delivery centers before reaching your door. That's similar to what a trace does in distributed tracing. It tracks a single request or transaction as it travels across multiple services or microservices in a cloud system. This process creates a full record of the request's journey, showing every step it takes along the way. A trace is made up of smaller parts called spans. Each span shows a specific operation or task performed by one service during the request. Think of each span as a snapshot of a single step, like a package being scanned at a warehouse. These spans are linked together in a parent-child relationship, forming a tree structure that shows how each step relates to the others. This helps teams see the order and timing of each operation. Every trace has a unique identifier called a trace identifier. This ID stays the same as the request moves through different services, making it easy to connect all the spans belonging to that request. Distributed tracing tools use this ID to gather and organize data, giving a clear picture of how requests flow through complex cloud environments. In cloud setups like Amazon Web Services, Microsoft Azure, or Google Cloud, traces are essential for understanding system performance. They help identify slowdowns, errors, or bottlenecks by showing exactly where delays happen. For example, if a user's request takes longer than expected, tracing can reveal whether the issue is in the database, the application server, or somewhere else. The technical side involves passing trace information between services, often through headers in HTTP requests or messaging protocols. This process is called context propagation. Applications are instrumented with code or agents that automatically capture spans, making it easier to gather data without manual effort. The collected trace data is stored in specialized backends and visualized through tools that display the information as waterfall charts or dependency graphs. In the world of cloud infrastructure, traces are especially useful in microservices architectures and serverless environments. They give visibility into how individual components work together, even when many services are involved in a single user action. Managed services like AWS X-Ray, Azure Monitor, Google Cloud Trace, and open-source tools like Jagger and Zipkin make it straightforward to capture and analyze traces. To sum up, a trace in distributed tracing is like a detailed map of a request's entire journey across multiple services. It's made up of linked spans that show each step's timing and relationship. This visibility helps teams troubleshoot faster, optimize performance, and keep cloud applications running smoothly.